Welcome to 5 Minutes VHDL Podcast, the podcast where we talk about VHDL and hardware design. In this episode, I want to talk about how to optimize the implementation of Multiplier in particular cases. As you know, the modern FPGA generally implements the multiplier macro inside. The multiplier macro are generally 18 by 18 multiplier or 18 by 19, the very modern FPGA. Some technology implements the 18 by 18 using two 9 by 9 multiplier. So if you need 9 by 9 or 9 by something less 9 multiplication, you can use two 9 by 9 multiplier instead of one 18 by 18. Anyway, some FPGA doesn't implement the multiplier macro. So if you need to multiply an operand by another operand, you need to synthesize the multiplier, and the multiplier is very demanding in terms of area and timing. So in this case, we have to optimize, if we can, the multiplier implementation. Okay, let's see an example. Suppose that you need to implement some multiplication where you have to multiply the first operand by sine of alpha and the second operand by cosine of alpha. In this case, if alpha varies in the range of 0 to pi, we have no possibility to optimize anything. But if our alpha argument is small, with small life, I mean plus or minus 10 degrees, in this case the sine of alpha is very small. So is a sine of 10 degree is about 0.17. while the cosine of alpha is 0.998, so is very close to 1. Optimizing sine of alpha, if we use, for example, 8 bits, sine of alpha is 22. Sine of minus alpha is minus 22. So in this case, we don't need all the 8 bits, but we need only 6 bits, because to represent plus or minus 22, 6 bit is enough. 6 bit is minus 32 plus 31. So for the sine is okay. The cosine is 0.98, so it's very close to 1. So quantizing with 8 bit, the quantization value is 125. So we still need 8-bit, but if you remember that any number x is equal to x minus 1 plus 1, in this case, cosine of alpha minus 1 plus 1 became, in the case of cosine 10 degree, 0.98 minus 1, that is 0.015 plus 1. In this case, if we quantize 0.998 minus 1 using 8-bit, the quantized value is minus 2. So we have minus 2 plus 128. So for the quantization of cosine, we don't need 8-bit, but 4-bit is enough, because we can represent minus 2 only with 4 bits and not 8. Of course, we have to add 128, that is 1 represented with 8 bits. But in this case is 1 followed by 7 zeros. And this is very simple to do. So we have to implement a multiply by first operand with the second one that is 4 bits only, not 8, plus an addition. If you want to go deeper with an example and the VHDL implementation of the multiplier optimization, you can go on my website. I put the link on the episode note. And if you have any question, you can write me using Telegram channel or the email. Talk soon and ciao.